Hello and welcome to this video that deals with properties of exponents. We're going to look at a specific property here, the property of dividing variable expressions that have same bases. The way I tried to lay this video out is similar to my previous video on multiplication, where there are many examples done in increasing difficulty. If you look on this window, this slide, next to the words that say easy examples, medium examples, harder examples, etc. In every title area, there should be a number that corresponds to the part in the video that you can fast forward to if you feel like you're achieving a level of mastery that you want to see harder problems sooner than later. The video is meant to be comprehensive in doing the easiest problems up to some harder problems, so you should be here in a review setting. You should have had this in class before. And if you're totally forgetting all of it, it'll take you through everything you need to be able to do decently quickly. But the goal, again, is to get up to the highest level of difficulty that you can achieve. So I've tried to lay this out in a way that it's helpful to everybody. Okay, so now, if you want to just take a quick pause and scan through the problems and maybe fast forward to where you want to go, I do encourage looking at the basic property and explanation no matter where you go next. So have a pause and look. Okay, so now that you're back, let's go on to the basic property and explanation for dividing variable expressions with the same. So the most basic problem I could give you here, I guess, would be something that looks a little bit like x squared over x, okay? And if I went backwards here to the idea of expanding what x squared is, you'd see that you have x times x over x. Well, at a very simple level, you'd think, well, anything over itself is 1, so I could kind of cancel out the x over the x, and then I'm just left with equal to x, which you could tell is x to the first, which I'll write very lightly there because you don't have to write it. So I guess here's the question. How did we get from this problem here to this answer here? Well, you can kind of look and say, well, this is x squared over x to the first, and say, well, I had an exponent of 2 on top in the numerator and an exponent of 1 in the denominator, and wound up with a exponent of 1 in the answer. So if you're saying, I probably subtracted the 2 and the 1 to get 1, you are in fact right. And the basic property that you want to be cognizant of here when you're doing division of same bases while applying the properties of exponents is that x to the a over x to the b is equal to x to the a minus b. Again, when you're dividing same bases, you can take the exponents and subtract them, keeping the base the same. Now, I want to throw something else in here that comes up in division that does not multiplication, okay, and it's this idea, that x to the a over x to the a equals 1. We could say, well, that's pretty obvious because anything over itself is 1. Well, I want to elaborate that property a little bit and actually use the rule and say I'm going to subtract the exponents. So I'll write the base and get x to the a minus a is x to the 0. Well, which one is it? Is it x to the 0 or 1? Well, in fact, it's 1 because, by definition, anything to the 0 power is 1. So you want to realize that anytime you're subtracting exponents and you get something raised to the 0 power, we prefer saying that it's 1. Okay? Also, too, if you're moving through a problem and you see anything over itself, when you cancel, the idea is 1. It's the same. And again, you should have seen that, so I'm kind of glancing over that a little bit for you. Okay, so here we are with some easy examples. You notice here my sort of property is written again. Okay, and I've got sort of a guide box here of a mind map telling us to divide the coefficients, write the base, and subtract the exponents. And you'll see I'll do that no matter how the difficulty level of these problems increases. So here I have a to the 10th, okay, divided by a to the 3rd in the first problem. The directions say, please simplify. Write your answers with positive exponents. That won't come into play so much in the easy problems, but it will as it gets a little bit harder. Okay, so I'm going to look here for a to the 10th over a to the 3rd, write the base of a, and then I'll subtract my exponents. 10 minus 3 is 7. And you say, well, what did you do with the coefficients? Well, in these easy problems here, if you notice, I have 1 as a coefficient there, 1 is a coefficient there. So getting to be a 1 is a coefficient there that I don't need to write. Okay, so in this second problem, we have negative 4x to the 7th divided by negative 3x to the 5th. So I will, in fact, divide my coefficients and get negative 4 over negative 3. It's just going to be the fraction 4/3 when I simplify it. Probably better to say that than round it off to a decimal of 1.3 repeating. I'm going to write my base, and then I'm going to subtract my exponents of 7 and 5 and get 2, making the answer 4/3 x squared. Okay, now in this next problem, I'll do it two ways, a little bit the longer way and then a little bit the shorter way. I'll do the longer way a little first and be formal here. Okay, I've got 10d divided by 2d, okay, and we will see that we'll divide the coefficients and get 5. Then we're going to write the base. Then we're going to subtract the exponents, which are both 1, and 1 minus 1 is 0. So I've got 5d to the 0, but don't forget that anything to the 0 power is 1. This will give me 5 times 1 is 5. Okay, that's the longer formal way. So if you went just back and looked at the problem and said, well, 10 over 2 is 5, and d over d cancels is 1, you don't need to write the 1, so it's really just 5. Both are completely acceptable. Okay, now we'll move over to some medium examples. Okay, and again, if you're just scrolling to this part, here's my sort of brain box here that's telling me some steps. Divide the coefficients, write the base, subtract the exponents. And again, this is kind of the basic property from a notation standpoint of x to the a divided by x to the b is equal to x to the a minus b. Again, notice it demonstrates how I'm subtracting the exponents. So directions say, please simplify, write your answer with positive exponents. So if you notice, some of these problems have negative exponents in them. We just have to make sure that we are aware of the negative exponent property. I'll show it to you on the next slide in the harder problems, okay, because it won't come up here too specifically. Actually, I'll show it to you 2 slides later on problems with examples of negative exponents. So let's just keep working through this idea where we have divide the coefficients, write the base, subtract the exponents. So I'm going to divide my coefficients and get 5, where I have 25 over 5. And then I'm going to write the base and subtract my exponents. 2 minus 1 is going to be 1, so I don't need to write it. Then if you notice quickly, y over y cancels, allowing me to say the answer is 5x. So in this next problem, where it's negative 36 m to the 7th n to the 8th divided by 14 m to the 6th n to the 2nd, I'm going to do the same thing. I'm going to focus on my coefficients of negative 36 divided by 14. Okay, and I know that 14 doesn't go into negative 36 evenly, so I'll just think of it as a fraction and see that the greatest common factor is 2. So I'll get negative 18 sevenths. Then I'll write my base, my first base here, which is m. Then I've got 7 minus 6 is 1, so I don't have to write the 1. That'll just fade out in a second using the magic pen. And now I've got, just to be careful here, my next base is n. And I'll write in the margin here, with a little dramatic pause, 8 minus negative 2. It's very common for kids to make a sign mistake when they do that. So I tend to write that out in the margin just a couple times so you can see that. So you actually wind up here with an exponent of 10, making the answer negative 18 sevenths mn to the 10th. And now in our third example, we have 3ab to the 4th times a squared b, all divided by 2ab to the negative 3rd. So if you notice here, the top actually has a multiplication in it, and I don't mind throwing that in on a medium problem. You should know how to handle that. So before I actually divide, I'm actually going to do the multiplication here, which you should remember is multiply the coefficients, write the base, add the exponents. So on top, I'm going to get, to start, 3a to the 3rd, because a's exponent there is 1, adding it to the exponent of 2, b to the 5th, because we have b to the 4th and b to the 1st. Okay? So, then all divided by 2ab to the negative 3. So now I'm going to use my division property and focus on dividing the coefficients, which is 3 halves or 1.5, which is not obnoxious to write because you're not rounding it or getting a repeating decimal. Write the base of a, subtract the exponents, which is 3 minus 1 is 2. Write the base of b, then subtract the exponents. Again, look in the margin, 5 minus negative 3. Okay, got to be careful of that sign, which gives me an exponent of 8. Okay, so that is my final answer of 1.5 a squared b to the 8th. Again, notice that I'm taking it in pieces, and I am never leaving this idea. Okay? So, if you've just scrolled here to the harder examples, again, notice that I'm going to use these ideas as steps in this box of dividing the coefficients, writing the base, subtracting the exponents, and it does kind of apply this notation here, which we have same bases with exponents being divided, so we will be subtracting the exponents. Okay, now, if these problems seem harder to you, I can't underscore enough the fact that I am going to be doing this idea no matter how hard they look. So it says, please simplify, write your answer with positive exponents. And we'll talk about just making sure that you understand the property of negative exponents on the next slide. Okay? So let's get to work on number 1 that says 35 a to the 7b over 15a to the negative 3b. Well, I'm going to divide my coefficients and realize that 15 doesn't go into 35, so I'll look for common factor, which is 5. That gives me 7/3, when I simplify that fraction. Then I will write the base, and again, I'm going to subtract the exponents, which I'll just go in the margin so you guys aren't too freaked out. 7b minus negative 3b is just 10b, making the answer 7/3 a to the 10b. Now, I'm sure you're thrown off by the fact that the exponent here has a variable in it, but oh well, that's all it is. Okay? I've done the same exact steps. Okay, I know it jumps out and you say, oh, it looks different, but I'm not changing the rules in any way. Okay? So, let's take a look now at this next example, number 2, where it says negative 0.12 m to the 12a plus b divided by 0.06 m to the 5a minus 3b. Okay, well, again, I'm going to divide the coefficients, Okay, I get negative 0.12 over 0.06 is going to be negative 2. If you're unsure of that, go on your calculator. I'll write the base, which is m, and then I'm going to subtract the exponents. Now, this is a little harder, I'll admit, because when you do 12a plus b, and you do 5a minus 3b, and you go to subtract them, a lot of kids want to say this, and it looks like the first green one I wrote minus the next green one I wrote. But in fact, it's not correct. You have to make sure that you set up quantity for the second exponent because it has multiple terms. Then take your time, go 12a plus b minus 5a plus 3b, because you're subtracting both those terms. The signs change. So that's going to give you what? 7a plus 4b for your exponent. So I get negative 2m to the 7a plus 4b as my answer. Okay? So, on this next one, again, it's a little trickier because I have a multiply here that I'll do before I do my divide. So I will, in fact, multiply coefficients, write bases, and add exponents. So if you notice here, this coefficient's a 1. So it's just going to give me what? 3. X to the 2a plus 5a is 7a. Writing the next base a y. And then adding 4 plus pi is just 4 plus pi because they're not like terms. Okay? Better to use pi there as an exact number than 3.14, which is rounded. Then I continue to copy my problem, which is 30 x to the 7a, y to the negative 5. Okay, so now I'm going to be applying this property here, because I'm concentrating on the division, and I get 3 divided by 30, which is 1/10. Now, if I see I've got x to the 7a over x to the 7a, well, last I checked, that just cancels because it's 1. Okay? Then the next part, I will write the base of y, and then I will subtract my exponents, which will be 4 plus pi minus -5, which will turn the minus negative into an add, combine like terms, and get 9 plus pi, making my answer 1/10 y to the 9 plus pi. Okay, so if you've just scrolled to this part, this is probably the hardest level of difficulty. Excuse me, I was on the wrong slide there just for a moment. Okay, so this is the hardest level of difficulty because it involves the negative exponent rule. And if you've watched all the slides, you've noticed they say, write your answer with positive exponents in the directions. Well, you should have some background in this, and I'll just go through this quickly. X to the negative a is equal to 1 over x to the a. Similarly, 1 over x to the negative a is equal to x to the a. And this is the negative exponent rule. Okay, basically it says if you have a base with a negative exponent, you can flip it and then change the sign of the exponent from negative to positive. It's considered to be simplified if the exponent is positive. So when it says write your answer with a positive exponent, you have to then apply this rule. Okay, so I have division here going on predominantly, so we're putting a focus on that, but I want to show you ones where these negative exponents come into play. Okay? So in example 1, it says 20xy to the negative 6th over 10x to the 7th y. So again, I'm going to try and follow this brain map here of divide the coefficients, write the base, subtract the exponents, okay, which is in fact this property in a nutshell. Okay, so I'm going to divide my coefficients and get 2, write my base, which is x, and then look at my exponents here that say 1 minus 7 is negative 6. Okay, so a little ding goes off in my head saying that exponent was negative. Come back to it in a second. Then I write my base of y, and then I'm going to do negative 6 minus 1 is negative 7. So now I realize here that I have 3 factors, 2, x, and y, and 2 of them have negative exponents. So again, you're only going to do this flip trick on the ones that have negative exponents. So I don't flip the 2 because its exponent is 1, which is positive. So I say 2 over x to the positive 6th, y to the positive 7th. And that's my final answer. Okay, let's take a look at another example here where it says 30 d to the 4th k to the 7th divided by 24 k to the 8th d to the negative 4th. Now, I have to be careful here a little bit with the order because the d's and the k's are not lined up so well. Okay, so you have to make sure you're matching your bases when you are operating them. So we have 30 over 24, and 24 doesn't go into 30, but they both have a common factor of 6. So when I go to divide my coefficients, I really just simplify the fraction and say I've got 5/4. And then I'm going to write my first base, which is d, and be very careful to do 4 minus negative 4. And be careful with your sign there because you get 8. Okay? Write my next base, which is k, and then do 7 minus 8, which is negative 1. And then I look and say, okay, I've got a base here that has a negative exponent, and that's k. So now when you go to sort of flip the k to the denominator, it's just kind of a reading thing. You got to realize, well, I already have a 4 in the denominator. So I realize that the 5 will stay in the numerator, and so will the d to the 8th. So I write 5d to the 8th. My 4 is already in the denominator, and I'm moving a factor of k to the bottom and changing its exponent to 1 from negative 1. Okay? So if you notice here, this is k to the negative 1 over 1. Here it's on top, and now it's on bottom. Here the exponent is negative, and on bottom it is in fact positive, and I don't have to write it. So my final answer here is just 5d to the 8th over 4k. Okay, so going on to this next example here, where it says, let's extend the page, 3x to the negative 4th, y to the negative 4th, times 6x to the negative 1, y to the negative 3, all divided by 30 x to the negative 6y squared. Well, if you notice, I have a multiplication going on, so I'm going to do that first. And again, that should be decently obvious of multiplying coefficients, writing bases, and adding exponents. So I've got 18x to the negative 4 plus negative 1 is negative 5. Y to the negative 4 plus negative 3 is negative 7. I'll write the bottom because I haven't done anything with that yet, the denominator. Okay? And then I'm going to I see that I have negatives, but I'm going to hold off here. Instead of doing any flipping with the negative exponent rule, I'm just going to try and stay with my division property here. Okay? So now I've got 18 over 30, which is a fraction that they both have a common factor of 3. So that is going to give me, oh, I'm sorry. They both have a common factor of 6, which gives me 3 over 10. Okay? And then I'm going to write my x to the, subtract the exponents. So be careful, negative 5 minus negative 6 will be 1. So I don't have to write the 1. Okay? And then I'm going to write my base of y, and then do negative 7 minus 2, and get negative 9. Now you see here for this final answer, I'm going to need to get rid of this negative exponent. So all my bases except the last one have a positive exponent. So I don't have to worry about flipping the 3/10 or flipping the x because their exponents are positive. It's just 1. Okay? So what's that going to give me here? It's going to give me a 3 on top and an x on top, the 10 in the numerator, move the y to the, 10 in the denominator, move the y to the denominator, and change the exponent to positive. Okay? So the answer is 3x over 10y to the 9th. I hope this was helpful. It was long for me to do, kind of a marathon, 22 minutes plus here it looks like. So I hope that you've found your level of difficulty that you need to practice on, and you are finding your way to doing that practice.